Hi everyone. So in this video, I'm going to explain to you how Fleming right-hand rule came about. Very similar to how I explained to you how Fleming left-hand rule came about. Now, in order to understand how Fleming right-hand rule came about, you also need to recall your Newton's third law of motion. That is, for every action, there's an equal but opposite reaction. Now for our start, what I've shown you here is a north pole and a south pole of a magnet, of two magnets. And right in the center, I have this conductor. You're looking at a cross-sectional view of the conductor. So this conductor is placed between the north and the south pole of the magnet, and the conductor is moved downwards. Okay, the conductor is moved downwards, right? And the direction of the current will flow such that you oppose the magnetic field. So how do we explain this? I'm going to break down this explanation into a simpler form. Okay, we're going to break it down in a simpler form. North to south pole. First, you have to establish that this is the magnetic field lines, north to south pole. So I'm just going to draw one magnetic field line to keep things as simple as I can. So when the conductor is moved downwards, by Newton's third law of motion, downwards was the action, so the reaction will be upwards. Therefore, in order for the conductor to be pushed upwards, the magnetic strength below the conductor has to be strengthened. And in order for the magnetic field strength below the conductor to be strengthened, the magnetic field has to be anti-clockwise. Because when it's anti-clockwise, you can see that the magnetic field strength, as I highlighted in green, will be stronger. The direction of the magnetic field to be induced has to be in an anti-clockwise direction, and by using right-hand grip rule, the current has to be coming out of the plane. So what is provided here is simply an explanation of how the current is induced. But there's a tool that can be used to determine the direction of the induced current, and this is known as the Fleming right-hand rule. Your thumb points in the direction of the motion of the conductor. Your first finger points in the direction of the magnetic field. And your second finger, commonly known as the middle finger, points in the direction of the induced current. And note the slight difference between Fleming left-hand rule and Fleming right-hand rule. In Fleming left-hand rule, we need to determine the direction of motion of the conductor, and in Fleming right-hand rule, we need to determine the direction of the current.